Hi, we are a group of five working on a project as a part of the business data mining course. We have come up with a predictive model that accurately forecasts real estate sales prices from both the consumer and the seller's perspective. It would improve decision making while facilitating fair and transparent transactions in the real estate market. There are multiple websites where the properties get listed and the price associated with them is quoted. But that comes entirely from the perspective of a seller. Here arises the need of a model that comes up with a price that gets calculated by considering various factors around the property. Buyers will benefit from having a reliable estimate of the fair market value of properties, enabling them to make informed decisions regarding purchase offers. On the other hand, sellers will have access to insights that help them set competitive prices, attract potential buyers, while maximizing their returns. Moreover, this project will cater to the demand for transparency in the real estate market using a data driven approach. The model makes use of significant factors impacting the accuracy, such as historical sales data, market trends, property features, location attributes, and many others. Let's have a look at the code where my friend Dheeraj will take us through the code and explain the business implications.
Hello. So we have designed the code structure in such a way that in beginning we have imported the packages and libraries required for this project. So NumPy, Pandas, Matplotlib, and Seaborn packages are imported, and along with that, some models like trend test, split, then metrics for evaluation, and models like linear regression, random forest regressor, and XGB regressor are imported. After that, the data is stored in houseprices.csv file. So we have used pd.trade function to read the data. Then, if we take a look at the data heads, we understand that there are 81 columns, so 81 attributes of the data here we can play with. And if we look at the description of data, we can see that for the quantitative attributes, uh, their ranges and their values with mean, standard deviation, and their percentile can be seen. Moving ahead, uh, from this analysis, we understand that out of 81 attributes, one is the ID of each buyer and seller, which is a unique identity of the buyer, and hence it cannot be treated as a variable. On the other hand, sales price is a dependent variable. So out of remaining 79 independent variables, 36 are quantitative variables and 43 are categorical variables. Some of the quantitative variables could be first floor space, second floor space, or overall quality, pool area, screen porch, etc. And some of the qualitative variables are building type, basement condition, basement exposure, street utilities, etc. So moving ahead, to understand the correlation between variables, we have tried to plot the correlation matrix in form of heat map, where we can visually understand the correlation among various variables. After going through this data, we came to understand that there are many strong correlations between variables. Garages seem to be built same year as houses. Basement have generally same area as first floor, which is pretty obvious. Garage area is strongly correlated with number of cars. Neighborhood is correlated with lots of other variables, and this confirms the idea that houses in same region share same characteristic. This input will help us devising a business strategy at the end of the project. Also, dwelling type is negatively correlated with kitchen above the great square feet. So these are some of the insights that we found through heat map. Moving ahead, uh, to perform the exploratory data analysis and obtained clean data for the model fitting and model predictions. We have tried to uh, understand the missing data values in the given dataset. So we realize that among 19 attributes, there are 5 having more than 50% of data missing. Uh, Moving ahead, we tried to uh, visualize the relations among various variables using box plot. Plotting box plot, we understand that for qualitative variables we have checked distribution of sales price with respect to variable values and enumerated them. Some categories seem to more diverse with respect to sales price than others. And one among them is neighborhood. Neighborhood has a big impact on house prices. Also, most expensive seems to be partial sales condition. Next implication is having pull on property seem to improve price substantially. There are also differences in variabilities between category values. So these are some of the insights that we have got from the visualization of the data, which is a part of exploratory data analysis. Now, moving ahead, uh, since we know the correlation among variables and we also understand that some variables are more correlated, means more important to understand their significance than others, we considered those variables having correlation between minus zero point 0.5 to zero point 0.5 and other we understand the variables which have correlation more than zero point 0.5 and the other one which have less correlation have been dropped from the data frame. After that, if we check at the missing values, we see that no missing values are available. Hence we can conclude that the our data is cleaned and is ready for the model. After that, another form of data visualization could be pair plot, where the variation of sales price with respect to each individual variable can be seen. Moving ahead, a pair plot can also be plotted for qualitative variables, where variation of sales price can be observed for different variables. So these are different types of data visualization. After that, moving ahead to the model training and building, we tried to divide the data in independent and dependent variables. Also, x and y as training data and testing data. Also, get dummies function is used to convert the categorical variable into numerical variables for model training. So if you look at the heads of training data we stored in x variable, we see that now we are ending up with 41 attributes. After that, performing the standard steps of regression modeling, x train, x test, y test on applying train test split and running linear regression model, we understand the evaluation in various variables known as mean absolute error, mean square error, root mean square error, and R2 score. These variables can be used to judge the accuracy of the model. If we look at the value of this variable for linear regression, we see that R2 score is 0.81 for linear regression. Similarly, random forest regressor uh, can be used for the same prediction, where R2 score is 0.87, which is higher than that of linear regression. Also, XGB regressor, uh, which stands for extra gradient boost regressor, can be used for prediction for which we are obtaining R2 score of 0.90. So if we compare different models, we understand that the R2 score of XG boost regressor is zero point 0.9, which is greater than that of random forest and linear regression, and hence XG boost model for prediction is more suitable than other models. Now, how we can use these models for the business purpose? So we, during exploratory data analysis, we understand that some variables are more important than others. For example, uh, having some particular kind of neighborhood has a great impact on sales price. Also, presence of pool makes a significant impact on improving sales price. So such insights could be used to derive a business strategy and segment the customers based on the offerings. Thank you.